Welcome. Today, we are diving into a really fascinating and, let's be honest, pretty radical question about the very fabric of reality. We're going to explore a critique that challenges one of the biggest cornerstones of modern physics, and it all kicks off with just a simple change in how you look at things. So, what if? What if time dilation and length contraction, those bizarre universe bending effects we've all heard about, what if they're not actually real? What if they're just a grand optical illusion? An illusion that comes from a simple, maybe even obvious geometric mistake made over a century ago. That's the provocative claim we are digging into right now. All right, to really get our heads around this, we have to step outside of our everyday experience. We're going to do a little thought experiment. So let's imagine we can travel to a vantage point way, way out in space and look back at our own solar system. Okay, let's set the scene. You are on the North Star Polaris, and for our purposes, your eye is what we'll call the camera eye. It's a single point that's just taking in all the light. Far below you, you see our solar system laid out on a flat plane. Now, this specific setup, it's absolutely crucial for understanding the rest of the argument. This brings us to a fundamental truth of our universe. Light isn't instant. It has a speed limit. So that image that's arriving at your camera eye way out on Polaris, it's not a snapshot of a single moment in time. The light you're seeing from the sun left 1,000 seconds ago, but the light from Earth, that's a tiny bit older. And the light from Jupiter is even older still, simply because it had to travel farther to get to you. So what does that really mean? It means the picture of the solar system you're seeing is a composite. It's like a mosaic made of different moments in time, the sun from one moment, Earth from another, and Jupiter from an even earlier one. And it all just happens to arrive at your eye at the exact same instant. It's not what's happening right now. It's not a true simultaneous reality. And that simple thought experiment, well, it cracks open the central idea of this whole critique. The argument is that for more than 100 years, physics has been mixing up two totally different ways of thinking about space. On one side, you've got what we'll call mathematical space. Think of it like a perfect abstract map, a God's eye view, where everything is at the exact same time, instantly. Then, on the other side, you've got observational space. This is the messy, delayed composite image that your camera eye actually sees in reality, where everything is a little bit in the past. And boom, here we are at the core of the critique. The big claim is about something called a procedural omission. The argument goes like this. Einstein took that messy, distorted image from observational space, and he analyzed it using the perfect, clean rules of mathematical space. But he allegedly skipped a step. He didn't correct for those light speed delays first. He didn't turn that messy picture back into an accurate map of a single moment in time. So, okay, how does this idea of a procedural omission actually play out? Let's take this new lens and apply it to one of the most famous thought experiments in all of physics, the light clock on Einstein's train. You've definitely seen this before, probably in a physics textbook, right? It's always a simple, flat, two-dimensional diagram. There's a train moving, a beam of light is bouncing straight up and down between a floor and a ceiling. And if you're standing on the ground watching it go by, the path looks like a triangle. Seems pretty straightforward. Well, here's the twist. This critique argues that this classic diagram makes the exact same mistake we talked about before. It's a flat map. In reality, you, the person watching the train, you're not on that 2D plane with it. You're standing some distance away. And that adds a third dimension that's almost always ignored, depth. So the observer and the train are actually on two separate parallel planes. Now, because you're standing back from the train, the light from the clock's ceiling and the light from the clock's floor have to travel slightly different distances to get to you. It's a tiny difference for sure. But this analysis claims that ignoring that tiny difference in travel time, basically treating two separate moments as if they were perfectly simultaneous, is the fundamental geometric mistake that the entire theory of relativity is built on. So if this is a mistake, what's the big deal? What does this alleged oversight actually lead to? What are the consequences for physics as we know it? Well, they're huge. This table really lays it all out. On the left, you have the standard interpretation from special relativity. Time dilation and length contraction are real physical things that actually happen to time and space. But on the right, you have this critique's conclusion. They aren't physical realities at all. They're perceptual artifacts, optical illusions, created by a failure to correct our observations for the delay in the speed of light. To really capture this massive shift in thinking, the analysis we're looking at uses a really powerful metaphor. It's about breaking free from a long, dark tunnel.
So this tunnel, it represents the world of special relativity, a world that, according to this argument, is a purely mathematical, abstract space, a place where the physical reality of how we actually see things, the position of our camera eye, the delays caused by light, is ignored. It's like being trapped in a maze that was built from a flawed map to begin with.
So what does exiting the tunnel mean? It means getting back to the real world. It means we should start with the raw, messy data our eyes actually receive, and then use the laws of geometry and the speed of light to work backwards, to reconstruct what truly happened, where it happened, and when it happened. And that leaves us with one last, really challenging question to chew on. Is the universe we see with our own eyes the real universe? Or is what we see just a distorted image? A collection of different pasts that we have to decode and correct before we can even begin to claim that we truly understand reality?